Hey everybody, so in this video we're going to talk about using function notation. This is something that we should be pretty familiar with since we talked about function notation at the very beginning of the semester and we've been using it throughout. We're going to review using function notation and then we're going to use it in some situations that we maybe haven't seen before. Okay, so let's look at our first example. Okay, so we're going to find each of the following values. Now part A is to find f of 5. Now this is the type of thing that we did talk about at the beginning of the semester, so we should be familiar with this. We know that we are inputting 5 into our equation here. So we're going to have 3 times 5 minus 1. Okay, and we know that the format of our answer should be f of 5 equals our numerical answer 14. Okay, so remember you are plugging this number into our equation, okay, and then your answer should be formatted like this, f of 5 equals, and then your answer. Okay, so that's a little review of what we've done. Okay, so let's talk about some stuff that we haven't really seen. Now, what if we want to plug in something that isn't a number, something like the variable a? Okay, so we're going to do the same thing that we did before. We're going to plug in a to our equation. Okay, so we would have 3 times a minus 1. Okay, now there's not really anything we can do to simplify this, right? 3 times a, we just write that as 3a, and we can't combine these two terms because they're not like terms. Okay, so this would actually be our final answer. Okay. All right, let's look at something real similar, but we're going to look at f of negative a. Okay. All right. So just to remind us of what our original equation was, we had f of x is 3x minus 1. Okay, so we're going to plug in negative a for x. So we have 3 times negative a minus 1. Okay, so this gives us, right, 3 times negative a we write as negative 3a, okay, minus 1. And again, we can't combine these two terms because they're not like terms. Okay, so you guys can see for B and C that there's not really a whole lot to do. You're kind of just showing that you understand what you're meant to do with the function notation and then rewriting it how we normally write our polynomials. Okay, let's look at one more example. Okay, so we're going to plug in x plus h. So again, here is our function f of x, okay? And we're going to plug in here x plus h. So we'll have 3 times x plus h minus 1, okay? So now we actually can simplify this a little bit because we can distribute our 3. So we'll have f of x plus h equals 3x plus 3h minus 1. Now we still can't combine any of these terms because they're not like terms. So this would be our final answer, but at least we got to do something in distributing this. Okay. So no matter what is the input for f of x, you can see that we are really just plugging in this value for x. Okay. Now let's look at another function. Okay, so this function is a little bit more complicated. Okay, so again, we're going to start off with something that we should know how to do. We're going to evaluate g of -1. Okay, so I'm going to plug in -1. So I'll have -1 squared plus 3 times -1 minus 5. Okay, now -1 squared I know is 1. This is going to be minus 3 minus 5. Okay, so this would be -7. Okay, and again, the formatting of our answer should be the question equals and then whatever your answer is. Okay, the things to pay attention to for this example are you have a negative and you're squaring it, so you want to make sure that you've got the sign right here. Okay, and then if this were a minus and this were a minus, you'd have to be attentive to the sign here also. Okay, let's look at another example. Okay, so we're going to take our function g of x, here I'll put down what g of x is, okay, and we're going to plug in -x. Okay, so we would have -x squared plus 3 times -x minus 4. Okay, now -x squared, we know that we can simplify that, right? X times -x is x squared. Okay, here I'm going to have minus 3x. Oops, I have -4 here, but minus 5 on the original problem. I'll put minus 5, sorry. Okay, which makes this minus 5. Okay, minus 5. Okay, just copied my own example wrong. All right. So here again, we can see the same thing that we saw in part A, where when you square a negative, you get a positive result, and we have this minus sign coming out in the front, right? This is exactly what we saw in part A. You're squaring a negative to get a positive, and when you multiply this positive times a negative, you get a negative symbol, right? So we're seeing that same situation here, okay? You might be wondering, why would you possibly plug in -x? Unfortunately, you are going to have to wait to get an answer to that question, but there is a property of functions that you test by plugging in -x. Okay? All right. Let's try another example. Okay, so now we're plugging in a plus 2. Okay, so again, remember this is what our original function is. Okay, so we're going to plug in a plus 2. So we'll have a plus 2 squared plus 3 times a plus 2 minus 5. Okay, so now we're going to multiply this out. Okay, and we're going to combine our like terms. Okay, so here we're going to get a squared plus 2a plus 2a plus 4. Okay, from multiplying this out, here we'll get 3a plus 6, and we still have our minus 5. Okay, so now we're going to look to combine like terms. Okay, so I have a squared. Then my a terms, I have 2 plus 2 plus 3, that's 7. Okay, and my constant terms, I have 4 plus 6, which is 10, minus 5 is 5. Okay, so that would be my final answer. Okay, so again, you're plugging in a plus 2 for x here, and then you're multiplying it out to simplify. Okay, let's look at one last example with this same function. Okay. g of x plus h minus g of x over h. Okay, so again, here's my function g of x. Okay, so I'm going to plug in x plus h. So I have x plus h squared plus 3 times x plus h, okay, minus 5. So that's just g of x plus h. Okay, then I'm going to subtract g of x, which is x squared plus 3x minus 5. Okay, and I'm going to divide everything by h. Okay, all right. So now for this part, I'm going to do exactly what I did in the previous example. I'm going to multiply this out, I'm going to multiply this out, and I'm going to add like terms. Okay, so here I'm going to get x squared plus xh plus xh plus h squared. Okay, from multiplying this out. Now here I get 3x plus 3h. Okay, and then I still have that minus 5. Okay, then I have minus x squared plus 3x minus 5 over h. Okay, so here I'm going to combine my like terms, and over here I'm going to distribute this negative sign. So I get x squared plus 2xh plus h squared. Okay, then I have 3x, 3h minus 5. Okay, now I'm going to do my subtraction. So I have minus x squared minus 3x plus 5. Okay, so over h. So let's look for like terms. I have x squared and x squared, right? X squared minus x squared is 0. I have plus 3x and I have minus 3x. Okay, I have minus 5 and plus 5. Okay, so all my like terms are canceling out. What do I have left? I have 2xh plus h squared plus 3h, okay, over h. Okay, now I can see these all share a factor of h, so I'm going to factor that out. Okay, and the benefit to that is now I can actually cancel this h from the numerator with this h from the denominator. Okay, and I'm getting my final answer, okay, 2x plus h plus 3. Okay, and again, we want to focus on the format of our answers. So if it's g of x plus h minus g of x over h, okay, equals our final answer, 2x plus h plus 3. Okay. All right. That's really all there is to this section. It is just expanding on what we know about using function notation and also doing some kind of computationally difficult problems like the one that we did here. So I will see you guys soon.